Solve the following nonlinear system of equations. 2x squared plus 3y squared is equal to 24 is the first equation, and the second equation is x squared minus y squared is equal to 7. Now, since all of the terms are squared, the best method to use is the addition method that we generally use for a linear system of equations, right? So the first step in that is to pick what variable to get rid of. And it looks like the y might be easier to get rid of, right? Because one of the y terms is already negative, so we've got half our work done for us. So now in order to cancel out these y's, when we add these two together, what we have to do is multiply the second equation by 3, right? Because then the coefficient for the y squared term is going to be negative 3, so that when we add them together, they're going to cancel out. So let's do that. So the first equation is going to stay the same. And the second equation, we're going to multiply each term by 3. So we get 3x squared minus 3y squared is equal to 7 times 3, which is 21. So now, adding these two guys together, we got 5x squared. The y's cancel out. And then on the right side, we have 45. So 5x squared is equal to 45. And when we divide both sides by 5, on the left side we get x squared, and then on the right side we get 9. So then to solve for x, we want to take the square root of both sides. So we get that x is equal to plus or minus the square root of 9, or plus or minus 3. So we have x is equal to 3 and x is equal to minus 3. And we've solved for x, but we're not quite done, because what we need to do is, since this is a system in two variables, we need to plug in these x's into one of the equations so that we can solve for y. So we want to plug x is equal to 3 and x is equal to minus 3 into one of the two equations above. And it looks like the second one might be a little bit easier to deal with because there aren't that many coefficients, right? So we want to plug this into x squared minus y squared is equal to 7. So now when x is equal to 3, the equation looks like 3 squared minus y squared is equal to 7. So 9 minus y squared is equal to 7. Then subtracting a 9 from both sides, we get minus y squared is equal to negative 2. And dividing both sides by 1, we get that y squared is equal to 2. So then, taking the square root of both sides, y is equal to plus or minus the square root of 2, which can't simplify. So, when writing the solution, we want to write the ordered pairs, right? So when x is equal to 3, y is equal to plus square root of 2 and minus square root of 2. So one of the solutions in this case is going to be 3 comma square root of 2, and the other solution is going to be 3 comma negative square root of 2, right? Because that's what happens when x is equal to 3. You get two values for the y. And now what we need to do is the same thing for x is equal to negative 3. So here we get negative 3 squared minus y squared is equal to 7, which reduces into 9 minus y squared is equal to 7. And notice that we're getting the same equation here. So it stands to reason, and reasoning correctly, that we're going to have the same solutions for y, right? So in this case also, y is equal to plus or minus the square root of 2. So then when we write these solutions down, we have x comma y, negative 3 comma positive square root of 2, and negative 3 comma negative square root of 2. So now, writing all of these solutions down, we want to say The solutions to the nonlinear system are, oh, excuse me, 3 comma square root of 2, 3 comma negative square root of 2, negative 3 comma square root of 2, and negative 3 comma negative square root of 2. So those are the 4 solutions that we found which solve that nonlinear system of equations.